Welcome to the Steel Building Workshop. I'm going to be starting out here in RISAFloor. In RISAFloor, what I have here is the ability to design a building in floor by floor. That's why we call it RISAFloor. So if I click here, I'm going to start a new floor plan, and I'm going to be looking at, I have either two options. One is a concrete floor slab, and that is more of our elevated slab design for a concrete, maybe two-way slab or one-way slab. But we're going to be focusing on a beam supported floor, and that's going to be more your traditional steel framing that we're going to be using. So the elevation here, I'm going to put in a 12 feet elevation, and then the rest of the defaults here I'll come back to. Let me just say okay, and we'll start out with a model. Now, the very first way you start out in a model is with a project grid. A project grid is something you would share with your architect, and that would be something like where we can lay out grid lines here. So I'm going to start within the z-axis, and that's going to be my horizontal direction. I'm going to say here this is going to be 4 increments of 20 feet, and then I just put a comma and a 5 increments of 22.5. I can do the same thing in the vertical direction. I'm just going to say 8 increments at 22.5. And then I'm going to go on and lay out here the Z and the X-axis. So I'm going to say it's from A to Z, and I just change here this direction. I like to have the vertical, the horizontal is going to be in numbers, and the vertical is going to be in letters. So I'm going to lay that out in a way that I can tell the program to preview this for me. And the way I do that is just say apply. If I wanted to make any change, say this wasn't what I was intending, I could just undo, make those changes there, and then keep going. So, but I'm in my model here, I think that worked out. I can say okay and go ahead and commit to that. The next thing you can do in your project grid, now your project grid is oriented in a spreadsheet, which is really helpful for you to organize or make changes. You can turn bubbles on and turn bubbles off if you need to. So if, for example, I can turn the bubble on and off here at the end of the start, you'll see that they disappear. But I'm going to keep those guys on. And what I'm going to do now is also going to be adding some in there. Now, using inside of the spreadsheet is an easy way to manipulate that project grid. It makes it very flexible, but I also can do things like just double clicking on a project grid itself to add things. So I can click on the project grid and it shows me that's a label B. I can make a change there. But what I want to do is copy this. So I'm going to copy it a certain distance away from my model. So I'll say I'm going to copy it and I'm going to call this a B.4, and the distance on that is going to be 10.33 feet, and I can say okay, and it will copy it above that line there. I'm going to also copy the B4 to another one here for B7, so I'll just copy this and I'll call this B.7, and I'm going to make that to be 6.9166 feet away from that line right there. So there we go. So now I have a few different lines that are all there in between that. So this is a 3-dimensional system, but what's nice is that it just allows us to look down on the model in 2 dimensions. Makes it very easy for us to model. So the next thing I'm going to do in here is I mentioned this is a gravity system that's going to be designing the loads down the system as a gravity model, but we're going to take the lateral system over to RISA 3D. So it's very important that we define things that we want to be considered lateral. They will still be considered gravity, but also lateral. Those pieces will maybe be defined first as our lateral system. We can then pull that will go over to RISA 3D later on. But today, here we'll start with just our lateral system on this level and see where we're going on that piece. So first thing to do the lateral system is to lay out here. I'm going to go ahead and do a column system. So we'll do a braced frame, and we'll do some elevator frames and elevator shafts in the middle of our building too. Now, the brace frames, when you'll notice here in the draw columns, is that I have hot rolled A992 wide flange. It doesn't specifically say what wide flange, because RISAFloor is going to design the columns based on whatever is needed. The design or the optimization is one of the big pluses you get out of RISAFloor, because the loads are carrying down the structure, and it's going to find the worst case it needs to put for either deflection or design, and then it's going to size that column and beam accordingly. So in this model here, I'm going to lay out that lateral system. and just say here A992 wide flange lateral and let the program think about what it needs to go and where. So starting out, I just lay out some columns. I can just rubber band around the areas that I need those columns. So I will just go ahead and say rubber band this in this direction. I'm going to, just as you see, I rubber band around the project grids. The column goes in place there. So I'm going to go ahead and do that over here. I'm going to go ahead and put this on this grid line 7, D to C. I put that over here. And the last but not least at the bottom here between 7 and 8. Now I have all of those columns in place, and when you go into a three-dimensional full model view, you see that the columns are there. So it is three-dimensional at all times, but it really just, as I mentioned, much easier to see it like this. I can zoom in really tight to see these columns. You'll see they're oriented this way. And we can rotate these columns that, for example, we're not going to want to go into the weak axis in this direction. So what I can do is I can turn those columns right there. So I can just modify their properties by going ahead and rotating them by 90 degrees. So I say use 90 degrees, rotate, and then I can just by rubber banding turn those columns in the direction I want them to be in their strong axes. So I've got all of those in place in the columns. Now I'm going to draw in the beams. The beams for these here are just my brace frames. So again, I just tell the program it's an A992, it's a wide flange, it's going to be lateral. I'm going to have it be in it's the strong axis. It's a pin because later on we'll put braces into this model. I can turn off the composite. It doesn't matter. In this case here in gravity, we can do gravity for composite, so that'll be okay. And then all I have to do is just rubber band right there, and I will be getting all of these beams here, and you'll notice you just rubber band around the areas you want, and it will then connect those. Again, I always like to just look back and see what it looks like in 3 dimensions to make sure I understand what I'm drawing in the past here. So beyond that, I will also want to put in some of my walls. So the walls are going to be in my elevator shafts that are going to go here and up here. And to do that, I'm going to use a tool that I have, which is the DXF underlay. To bring the DXF underlays, we just go ahead and use our drawing grid. Now the drawing grid can be laid out anywhere in more of a kind of a format like a stencil paper. But drawing grid is usually a 30 at 30, kind of 30 by 1 at 31 feet around the building. I can change this, I can do skewed, different things in there. But what I'm going to show you right now is the DXF import. Now this allows us to import something into your model at a given location, and I can pull up a DXF to draw behind that. So I want to draw these elevator bays here. I'm going to go ahead and browse, and I can get to my desktop here. I'm going to go ahead and pick up a DXF that I have. And in here I tell the program what color that DXF should be. So when I say select from layers, I can use different colors to define here. This little gray box is going to mean it's going to come in as gray, but I'm going to change this to be just kind of a brighter green because I'd like to see it pop on my screen here behind all of the rest of the model. And then what I also do is I see here, I actually brought it in at 0, 0, 0 location, but I'd like to change that. Instead of having it 0, 0 location, I'm going to move it over because I know my drawing grid in my DXF was drawn really more to true elevation of where that building is being placed in the lot size. But I'm going to say it's going to be over here, scoot it over a bit, and I just pick up that file one more time, make that green, and then I can just tell it to go right where I want it to be, which is right here. So whatever's on that DXF layer shows right on the screen, which is really helpful for drawing now, tracing these walls as I draw around it. For walls, I tell the program a little bit of information about that wall. So before I pop into here, I can tell it's a concrete wall and 3,000, 4,000, whatever material I want. I would define that before I get in here. And I'm going to say it's going to be 4,000 normal weight with a design rule of typical. And I'll pop over to the design rules here in a second. But these are also going to be lateral walls. It's important that we're drawing our lateral system here. So when we call that lateral, it means it's going to go to RISA 3D for lateral design. So now I start drawing and I say apply. And I just can trace behind here. So I'm going to just trace around and walk around the structure here. And I have to be able to trace. I can just zoom in a bit here. And I can close these walls off here. There we go. And I'm going to go ahead and trace over here too. And I'll create these walls all around my structure. There we go. Last wall. There. Okay. Now I can double click on any one of those walls and I can create openings in this wall. So I can put in an opening, and what you'll see is it's got a rendered look, like a concrete rendering here. I can just turn that off, and I have a grid system right in here. It's a different grid system. Sometimes you'll want to set up a grid that's specific to your model. For example, maybe 1 foot at 1 foot, or you could tell the program a specific dimension if it's important here, like a certain distance from that wall you want to start drawing. So you can actually say, okay, I actually want to draw that maybe 19 feet in, 4, which means that it's going to be, the grid is going to have a different line up here. So this is at 19 feet from the edge there. So I can draw that in, and I'm going to just drop in a little opening. There we go. So you can see what that looks like underneath there. Internally, the program creates regions for these design regions. And so all of these walls will have a design region for reinforcement design. In concrete, you'd want to go into your wall design rules, and for concrete, you'd want to tell the program specifically what your vertical bar sizes should be, what you're going to be the spacing for those sizes, the horizontal bar spacing, and the bar size and the spacings, and then the increments that you want to increase that by. You can also tell it information about what should be the outer bar, the vertical or the horizontal, and then the location of that reinforcement, the interior and the exterior cover, and information about what you're going to do over those openings and above and below the openings. You can define all of these walls here. I'm just going to put in a little bit of another opening in here. So I'm going to go ahead and call this to be 1 foot as my grid, and I'm going to drop in another little opening so we have some openings in these walls. There we go. And I can see now. So looking again in that 3-dimensional model, you see now I have openings in these walls. I have concrete as well as my brace frame is started here. And then we're going to start to continue to design the rest of the structure. We just really started with the lateral system, but the big piece is to drop in our gravity system. So to do that, I go ahead and I draw in more columns. This time I'm going to go straight to the draw columns, and everything is going to be the same, except it's going to be gravity now instead of lateral. And I start drawing this in by just rubber banding around as I did earlier. You don't have to worry if you go over a top of another column. It will not cause a duplicate. It'll just not include that one in that location. So I'm going to go ahead and turn off my grid below there. So there we go. And I'm going to go just rubber band all across to create more and more columns. And I have almost everything laid out. So this structure is an L-shaped structure, but what makes it more interesting is I've got a few columns here in the center that kind of make this foyer area flush out a bit there. So we're going to see that column line F is going to be shown here, and we're going to see a little bit more of that step out around that structure there. So let me go ahead and just delete this one column out there. There we go. So the rest of the structure, we'll then draw our beam system in there too. It looks like I missed a few columns. Let me go back and put those columns in there. There we go. And I've got all these columns in place. Okay, now the beam system. So the beam system, again, we just define this gravity, and we'll just draw this around the structure point to point, and I can just continue to rubber band most of the structure, right? I can just really do a lot of rubber banding. Very easy to do that, and then connect some bays that are not connected like that. But then you'll find that there's areas that you want to connect, but it's not as easy. There maybe not be a snap point for you. It's easy to do those things here. For example, I want to close this off this area, but I can see that the snap points I have, maybe third points and things like that, maybe not work for me. So the way you can do that is we have a lot of tools in here called draw point to point, which is what we've been using. But we have tools here like draw a beam to a certain location. So for example, I can draw from a 0 offset to a certain angle, and I want to go at 90 degrees from this location here. So I'm going to say this is 90 degrees, and I'm just going to say it's from the horizontal, and I can click on that point there, and now I can click to that. It's going to find this at 90 degrees. It looks like here. Let me try that one more time. I'm going to go ahead and say, let's actually do that from 90. Let's do a 0 degrees. Excuse me. On this piece, it's going to be 0. This is going to be from the horizontal, as in 0 degrees is going to be, 90 would be this direction here, so 0 would be horizontal. I can do that over here, and I can do that same thing, recall that last dialogue, and do it again down here. So I'm going to go ahead and click on that point right there and go there. There we go. Now this will be 90 degrees, so we can go ahead and draw in these, switch that to be 90 degrees from the horizontal, and that would be correct over here. So recall last dialogue, and I will pull that up right down here. So I'm just closing off this. Now, what I have, if I push my F5 button, I have a distance. Remember that from our drawing grid. That's going to be about 22.5 feet. It's a little bit long span, right, to have anything framing that distance. We want to have some infill framing. And we can do infill framing really quickly in RISAFloor by telling the program a few things. Similarly, it's an A992 wide flange composite beam system. But what I'm going to say is going to be that I'm going to have an equal spacing not to exceed 8 feet. And I'm going to start with a vertical direction. So by defining it's going to be vertical, I just select that there. And then I'm going to go ahead and define this directionally in a few different areas of my model. So I'm going to kind of rubber band this whole area, and automatically I get all my beams vertically in those directions. This directions, for some reason, we're going to change directions. Maybe the HVAC or something is changing. So I'm going to go horizontally in this area. And I can do that just by going to horizontal and then just rubber banding this area. Now all of a sudden I have all of these in place as well. So I made a few little, whoopsies inside of here, no problem. You can just delete them. Super easy to clean up anything that you want to get rid of in the middle of those areas. And now I see I have my elevators are free and clear. Another couple things that you'll notice along the way if you need to make changes to, it's so easy to do in RISAFloor, just like it would be in RISA 3D. You can make modifications to the model. So if somehow you make a decision that maybe this whole area that I have right here, this whole column range here needs to move out, you have to have it extended off by about 4 3/4 feet for some reason. You can do that. You can move a whole area, so you can just unselect everything and select just that area, and then you can use your move command. Now the move command will just ask, hey, where do you want to move this to? We want to move it in the X direction. We're going to go 4.75, and we're going to move a whole selected area and just say apply. It'll ask me, do I want to move a single column or an entire stack? Now, we have to remember this is a multiple story building analysis tool. So a lot of times we might have a whole stack of columns. In this case, we really only have one. We only have a single floor, so it's no big deal. I can just leave that and say, remember this answer, and it scoots it all out. Now, when it scooted it out, it brought all the things attached to it, like these two columns, and then those beams followed with. But these beams, they weren't defined along that way. They're defined by this node. So the quickest way to fix that is to use the extend the member tool. And using that tool, you can just click on the member that you want to extend, then click to the member you're extending it to. So click and then click to that member, and now all of a sudden that whole area is corrected. Really easy to do that. Another way we can do things is we can extend maybe a fascia area. Maybe we want to have a whole deck or patio region on this side of the structure. And to do that, we can tell the program here, instead of drawing a member, we can use our cantilever function here. So we have a couple things here. We have either cantilevers or outriggers. Later on, we'll talk about outriggers. But in this case, I'm going to be doing a cantilever. And it means I'm going to have a backspan of the beam behind it. But this is going to cantilever a 7.5 feet out. And so I just then click on the edge I want to cantilever out. And this is telling the program that this is a special condition of a cantilever. So doing that, and then I also want to close the framing. So I'm going to draw another member out here. I'm just going to say draw point to point, and I'm going to draw this across this area right here. I'm going to what that did is you'll note it always kind of defaults to breaking the member up. But in a fashion that I really want to do is more of a extended full distance beam there, so it acts a little bit more of a continuous beam. So I'm going to uncheck this here. I'm going to make sure to keep the spans continuous and draw that right across there. There we go. So now I have my whole structure defined. The next piece to worry about is to talk about the diaphragm. So the diaphragm and the deck, those are two things that go hand in hand. And the diaphragm is more for an analysis when we talk about the lateral portion. But you do need to have a diaphragm edge around the entire structure. Either maybe this whole thing is not contained in one diaphragm. We need to define that. The diaphragm you define really quickly in one spot. It's super easy. You just say, I'm going to have an overhang of a certain distance, and it's going to be a rigid diaphragm. Click apply, and it will then connect all of this as a diaphragm edge. I'm just going to show you have 3 different options for diaphragms. We'll come back to different types of options, but you can do rigid, flexible, or semi-rigid. And I'm going to say apply and have a rigid diaphragm around the entire edge. By doing that, I inherently have a deck internally on this as well. Now, decks are different than diaphragms. Diaphragms are how are we going to distribute the loads laterally. A deck is about how are we going to define how the loads are attributed inside of this gravity model. So for us, we want to do a composite deck, and we'll see inside of here we have a composite deck and we have a database of different composite decks. So let me open up this composite deck and let's look at what kind of thing we're going to do here. So I'm going to choose a Volcraft, and I have a Volcraft 1.5 VL. So I'm going to pick up this deck database here, and I have a whole different list of decks that I can define. In my model here, I'm going to choose a 4,000 normal weight so that it lines up with the rest of my concrete strength that I use for my walls. I want to use the same concrete strength for my deck. And then I'm going to pick up a deck that's going to be good for me here. So it'll be just, let's do a 4-inch normal weight, and we'll just do a 20 gauge there. So I'm going to say, okay, this is where you define your studs. If it's shored, you define that here too. But I'm going to say this is going to be good for my studs, and I will define that there. This just echoes that back. It just kind of lists out the things that I made the assumptions on. The program will use an unbraced length for the top flange of any one of my beams here based on this. This is my 2-foot unbraced length. And then I have a max span. Now, span is interesting here. By default, there is a deck that I told you here. That default deck comes off of my floor spreadsheet. When I look at my beam floor spreadsheet, this was right off when we started a new floor level. We ignored this part, but we're coming back to it now. We have a default deck, and this is the fastest, easiest way to do it. Just let the defaults work for you. They define everything, and you can just work around the areas that are not default or are not the background way that we want to do it. So in this case, I'm going to go 0 degrees, which I mentioned was horizontal, from the horizontal 0 degrees. And I see that deck is running horizontally across my screen. And that looks great. I want the loads to attribute horizontally across the screen. That doesn't really make sense up here. This is going to be vertical, right? We want to change that deck direction in this area. So the quickest way to define that deck is just to go ahead and unselect everything and then just select the portion you want to change. So I'm going to go ahead and select this portion right here. I'm going to just grab anything in that area. I'm going to turn off that deck for a second here just because it's easier to see. And then I will go ahead and put on that composite deck in the planned vertical direction. So I just go box that in. We see that shows up here. It's in green. And then I can turn back on the rest of the model and you'll see here this is going to be as with default in the background, and this is going to be the deck that overrides it. So once I have all of that in place, this is going to give us the other piece about that deck is there's going to be some inherent self-weight with that composite deck. We can add superimposed dead load onto it. So any construction dead load or live load can be added into that composite deck if we need it to be. So at that level, you're done. But let's say somebody gave you a call back and says, actually, you need to make a quick change in this corner. There's an offset problem. The property line is too close and we need to trim that back. Not a problem. We can do things like that super easy too to make those changes. So I can go ahead and say, okay, let's go ahead and change that from gravity. This one, we're going to cut it right back there. And I'm going to delete some of these different columns / beams that I have out here. So I just delete them, no problem. I'm going to go ahead and get rid of that. And the bigger piece though, I want to trim this back. So I'm going to go ahead using, instead of the extend the member, I'm going to trim the member. So go ahead and just trim it right back to the members that I want there. Lastly, that diaphragm is in the way. The diaphragm you can just delete and redraw, or we have some modification tools. So you can either redraw the edges. I'm going to merge those edges right there. I can just click a merge and say merge these two edges together, and it just combines them across that area. And then I'm ready to go with that diaphragm. So all I have to do now is kind of worry through some of my loads at this point. And so let's take a look at the loading we have on this model. So each floor, as I mentioned, has some inherent defaults. And the thing we are right now defaulting to is our office load. So our area load is defaulted all across the entire structure as the office area load. If I go to my area loads direction here, so I've got an area loads definitions, I can see inside of that, we have an office area load, which defines either a pre-composite and a post-composite dead load. In my model here, I can put in a little bit of pre-composite. Let's just say let's do a very small amount of pre-composite. I can put post-composite dead load. Live load is going to be assigned right here. I can do, this live load can be reducible, non-reducible, it can be special, it can be roof live load or rain loads. You have all sorts of different options, snow loads to do that as that live load. The vibration analysis is going to be defined right here, and we'll see that after we run the analysis. The dynamic mass or dynamic loading is what's going to be taken over to RISA 3D. So most typically you want to match the dynamic mass to your post-composite dead load. There may be cases where you don't want that to be exact. Maybe you've overemphasized what your dead load is and you want to get it to be more fine-tuned. You might have these numbers be different. So in our model here, what I do want to do is I want to go ahead and put some additional loads into it because that's our area loads for the entire structure. What you'll notice here is you have another way you can do some additional area loads, and I'm going to do some additional my public load here. So I've got a way to do public load. It's going to be replacive, which means if I put public load in an area, it is going to replace the loads that I have instead of the office loads is going to use public. So around maybe my elevator bays, let's define some public load and see how that works. So if I go ahead and say public and I use point to point, I can define this in a certain area, and I'm going to go ahead and just draw this over this area as a public area over the entire structure, or in this area, excuse me. And when I look at this with the default turned on, I'll note that it shows me that the public area is in place of the office area. And there's a little key at the upper right corner to explain that to me. I can also put in an additive loading. So this additive loading shows me that I'm going to be putting piping. So piping means like when I run pipe across this, it doesn't replace the dead load or the live load. It's an additional load, and that's where that checkbox for additive comes into place. So I'm going to go ahead and put this piping load, and I'll switch this to add piping, and you'll see here when I drop in the piping here, it's going to, maybe we'll go all the way across here for the piping, and we'll tie this back in over here. There we go. Now the piping load is right in here. So you can put in piping load, you can put in any of those things in there. The other thing you can do is you can put in different types of point loads in the model. Point loads can be placed anywhere in the structure as a post-composite, pre-composite, live load. Any of the different things we just saw can be also in point loads. So maybe I'll just demonstrate this with a few point loads. Now for point loads, it is always fun to see where you can put point loads. I always think of point loads can go on a beam, right? But they can go right off a beam too. So you can put them right on off your structure. You don't have to put them right onto each beam. It'll get allocated to the beams that are nearby, so that I can stick those in. I can also do line loads. So line loads, I'm going to show you a little different way. I have a cool tool that does line loads. So say we wanted to do on the exterior of the structure, on the lower levels of this structure, we want to do a brick ledger. And we can do that easily by picking up using an unselect tool. And then I use a tool here using the criteria. And I'm going to pick up all of the beams in my model that are the perimeter beams. So it's going to find anything around the perimeter and say, okay, and it finds all of these beams. And then I can apply a distributed load for the exterior loading there for that brick ledger. So to do that, I can go ahead and just drop in a load, and this load here we'll put in as, let's say it's going to be 0.4, which is going to be kips per running foot, or 400 pounds per running foot, and apply it to all selected members there. I'm going to unselect that guy, and there we go. And then I can just draw it from point to point on this section right over here. So I can just go back and just draw that in from a point to close off right there. There we go. So this is going to be a 0.4 kips per running foot all across the entire exterior of the structure. And now I am ready to move off this floor. So what I want to do on this floor, we can just review this before we leave this floor level, is to see I have a single story, and the next thing to do is start to really work up the building. So I can say insert floor, and I can come in here, and then I'm going to do first a couple things. You could copy it, and I could just copy each floor level, but what is a nice really benefit is that if this floor is very similar to the floors, if it's like a typical basement floor, why not I just use this child floor? And the child and parent relationship allows us to have a more typical floor where you can make changes on the typical floor, and all of those changes get adjusted into the child floor. So let me see, this is a way to do that here. I'm going to just go ahead and say this is a child floor at 24 feet. I'm going to use a composite deck, office area load, and that default deck angle was 0, and I go ahead and say okay. Anything that happens over here is going to be shown right in the floor level below. So that's really common to do that. If, say, we had a lot of different floors that we were doing things like that, we might use our child and parent floor. But the next floor level I want to do is going to be a copy, because I'm going to start making real changes on that floor level, and I don't want to make them on every floor level. So this floor, I'm going to say this is going to be a copy of floor plan 1. And I'm going to say it's at 36 feet. And it's going to have as an office with a composite deck. And I say okay. And now I'm looking at this floor level, and I brought everything across. I just made that decision to carry every single thing across. But I could have also decided to bring certain things across. I could have brought in just columns, beams, different things like that. I brought the whole thing across. And that's okay, because now I'm going to start making those changes. And they're minor at this floor level. So I'm going to go ahead and delete the diaphragm and delete that around the edges there. And then I'm going to start to delete other portions of that. So I'm going to go ahead and delete, for example, I'm going to get rid of these guys here. And I'm going to go ahead and just click around and delete a few of these things. I'm going to start to frame this area so it's a little bit tighter. So I can go ahead and delete this whole column. Remember that answer right there, and this column here, and we go ahead and do that. I'm going to frame this as well, but I always have a hard time imagining that. I'm going to draw that member first, trim it back, and then I'll go ahead and draw and trim it and delete the rest there. So I'm going to go ahead and draw that across, and then I'm going to delete and trim there. So first I trim. So trim the member. Remember, you just click on the end of the member you want to trim to, and then back to the member you're trimming it to. So I click on those, and then I can delete that section over here. So this whole area just got framed back. We're setting kind of a very typical way to move up a structure. The building gets a little bit more narrow, and we lose that framing in that area. So I'm looking here, and I'm going to go back into my full building model. Now I'm on my 3rd floor. So I fully completed my 3rd floor. I'm looking at the structure, and it is going up nicely. The next level to do here, I'm going to go back up to 3rd floor and say insert floor. And this time I'm going to go to my 4th floor, and I'm going to make a copy, but this time a copy of the 3rd floor. We've already done the work to trim back this area. So that area now is going to be my 4th floor, and it's going to be a copy. And then the location of this is going to be at 48 feet. We can say okay, and I then create this. Now this floor is going to be just a simple copy at this level, but I want to start to work on deleting other things at this level. So this is 48 feet here. Let's double check here. We've got 48 feet all the way up the structure, and now I'm going to, at this level, I'm going to start to remove some of the sections I have there. So this whole area is going to be starting to trim back. So the way I can do that is just by unselecting a large portion of the model and then selecting this using the group selection. And I'm going to pick up this whole area, and I'm going to basically remove a lot of this area here. So I can do this quickly by just saying delete. So deleting all of the things on this level here, just in this area. I'm going to go ahead and say delete beams, delete columns, delete walls, and say apply, and remove them all from a single level there. So I'm going to go okay, okay, oops, I remember this answer, and I've got that all set. The other piece to do that is to go ahead and I'm just going to change the framing so everything is going in the same direction in that. So I'll click and delete these areas and frame it back the other way. So I'll go ahead and say plan vertical, and I've got these in place. Okay, so let's go back in here. So one of the things we forgot to do at this level is to put back the diaphragm edge on there. No problem, that was super easy to put the diaphragm edge on. I just said apply, and there's a diaphragm edge on the 3rd floor. Now on the 4th floor, I can put a diaphragm edge on this level because I am complete over there. And one other thing I didn't mention is that those diaphragm edges, I did not define the openings inside of this elevator bay. Really easy to do that. I can go ahead and put a diaphragm opening anywhere just by clicking right inside of that opening area. What I like to show here is that by doing that on that floor level, I just did it on the child floor too. That was the floor plan 1 was the parent floor, and the child floor got the changes. This is where that really pays off. If you have a large amount of changes on that parent floor, it will be reflected on the child floor. Not so much on the next floor, right? Because I am making this one on its own, but it's not a big deal. We'll go ahead and go through there and put these in, and then we'll go up to the next floor level and do the same thing. So I've got openings on each floor. There we go. And I can then continue up the structure. Okay, now once we get in here, one of the things we might consider as we go back down, if we're thinking about how this works, I actually like to see this a little bit too, is that you can always turn on the floor below. So you really can think about how the structure was working underneath that area. And we have a miscellaneous show floor below. This one will show us in this color, right? This blue color that we're using right here. If we say okay, you'll see it shows up. And this is what it outline looks like at the floor level, right below the level we're looking at. So in level 3, you can see that you've got this area shown below that. In level 4, this is the level that shows us all that information. So what is happening on that floor level below is that there is a little bit of a deck change happening here, right? So when we think about it, that this level, this is actually exposed to the elements at this area here. So when we're thinking about that deck that we placed on there, that composite deck, this is now exposed to the elements. We can change the deck, we can change the loading. Let's say it's still composite, but I do think I want to put a roof loading in this area. So instead of using my composite, my office loading in this area, as I did there, I'm going to change the area loads over here to be that roof load. And to do that, all you have to do is, first I'm actually going to unselect everything, select only the portion I want to grab here. So I'm going to get this area here, like right over there. There we go. And then I'm going to go ahead and put in, this is we're going to call is roof loading. And I'm going to go ahead and draw a box around that. And I should be able to just replace that there. There we go. So I might need to do a little bit of a point to point to correct that area right there. So let's go ahead and show you point to point. So I'll go in here, point to point, and I'm just going to replace this area right here. And this is now my roof area. There we go. Okay, so I have all of that now is exposed and is being using my area loads from my roof. If we want to go respond to that, that was just to refresh our memories. That was a 10 pounds per square foot, 20 pounds per square foot of live load. That's all in that area right there. Okay, going up the structure, we're now on floor plan 4, and I'm going to turn off that underneath there just because now we don't want to see it. One thing we do note is that we probably now want to copy all of our loads there. So we can delete those loads that we have here. You can just delete by clicking on them, and let me just show you, actually, sorry, delete by the selected loads that we see, those line loads. I'm going to just delete all of that right there. I'm assuming that all of those line loads are only on those first couple floors. Those maybe were meant for if we were doing like a storefront area, but up here I wouldn't be doing them. So when you make those decisions about what to copy, that's important to note. Okay, so moving up the structure, I'm going to keep going. And the next thing to worry about is at the next floor level. So I'm at floor level 48, and I'm going to go ahead and say insert floor. So go ahead and insert the floor, and this is going to be, the next floor is going to be a copy of the floor below. I'm going to say this is going to be floor plan 4, and I'm going to copy it up to elevation 60. It's going to be a composite deck with office area load, and then I'll go ahead and say okay, and I've got this floor level here. Okay, now from this point here, I'm going to go ahead and I'm going to really cut down the structure here. So to do that, I'm going to delete that diaphragm edge off the edges. Not a problem, one click. And I really want to try to trim a lot of this area down. Again, I can just push delete one at a time, but it might be easier to just grab a few things using our selection tools. We know we want a lot of these things gone. So I'm just going to go walk around the structure and delete these things right out of the model. There we go. And I've got that there and here, and we can kind of see this as we go around. We're now finished in that area there. And I'm going to go ahead and push delete, and I'll delete the beams, and I'll go ahead and say apply. A few of these columns I want to keep, not all of them, but a few. So I'm going to go ahead and keep a few of those. I'm going to just hand pick the ones I want. I know I want this area here, but I do want to delete this one. And I'm going to delete these guys here. Oops, not that guy. How about the column? And undo is always my friend as I work around the structure. And I'm going to leave that area right there. There we go. Okay. So next piece is just to connect these frames, and we have a kind of a triangular section in this area that is going to help frame out the side of the building. So we're kind of making a very interesting section as we keep going, but the last piece is to just fill this framing in, and it's going to be vertical in this direction here. And we're really just staying let's just do a little bit of framing, close this off there, and we'll tie that off, and then we'll just add in our framing vertically there. There we go, and I've got it all there. We can put on the diaphragm one more time back onto the structure. I'm going to go ahead and put that diaphragm right back on. Oops, I think I'm in there we go. Diaphragm edge, there we go. And we can start to build the next floor level. So we can go ahead and say, let's go insert floor, and we'll be at the copying of the floor plan 5. We're going to go ahead and copy that at 72 feet. And everything else is remembered. I can just say apply, and I go from here. Now I'm on floor plan, let's see here, 6. And this floor plan, I'm going to start to really trim back this area. So we get into this diamond structure we're going to be building. So I'm going to delete a lot of this stuff, but let's see. I'm going to first delete is the diaphragm edge. Good to get rid of that first. And then I'll go ahead and unselect everything in my model. Just select the portions that I'm interested in. So I'll kind of cut across here and pick these up. So I'm going to get rid of all of this stuff, and actually I might box this because it just might, well, let's do a few of these things. It's just a lot of different ways to do, what's the easiest and fastest way to grab the things you want to grab. So I'm going to go ahead and just grab all of this area like that, and then I'm going to come back and pick up the area that I want to keep. So I want to keep this area here, and I want to keep all of, I'm going to go ahead and say, keep this area over here and over here. And then lastly, I want to just grab all of these columns and select those. So let's go ahead and unselect these areas here. There we go. Okay. We can then delete all of the rest of the model in this area. So using the delete tool, I can say like delete based on selected items, the beams and the columns, say apply, and remember this, and then all of that's gone. And we can then draw in what looks like more like a diamond in this area. So we'll go ahead and say draw, and it's really long span, but it actually is kind of fun to do this because we're going to see it's going to get a nice cool camber in this area, which is just kind of an interesting artifact of the fact that it's so long. So we've got here, I'm framing this in, and then I'm going to go ahead and put in my infill framing. So the infill framing, I'll just connect these guys there. Oops, I'm going to actually connect them so that they break. So I'll keep off the continuous spans. There we go. Okay, so the infill framing here, it's going to be a little bit different. I'm going to go horizontal in this direction, horizontal here, and then I'm going to go vertical, actually in this diagonal direction. So you have a lot of ability to do those things. So in this case here, I'm just going to easily click in these areas to create that horizontal. But I do want this, directionally. So the diamond frame that I want to put in here, I can put that in at 45 degrees. You can really do any direction you want, but you can decide kind of what you need here. So angle to The beam, I'm going to actually angle from the horizontal is going to be 45 degrees. And I can just apply that right into the structure. Oops, hold on, let me just recall last dialogue. And this is going to be actually there. There we go. I could have done it angle from a beam as well, like maybe 90 degrees from this beam if I wanted to do it that way too. So like I said, lots of different ways to do the same thing. But once I put a diaphragm edge around it again, that's all good, but probably my deck doesn't work. So let's get rid of this deck, this old deck I have in that place right there. And I want to do a deck here that's going to make sense. It makes sense to be horizontal in this direction. We need a vertical deck in this direction, and then we need a diagonal deck in this direction. So we need a kind of a mixture. This one's all covered. I don't have to worry there. So I'm going to unselect that. But I am going to start to worry through this area. And it just makes your life a lot easier if you base things on your selection, because you don't have the worry that you may click on the wrong thing if your selections are already done. So what I always try to do is like pick out the members that I really want to make sure I'm getting. And then I can define things so that they pick these things up. Like I want a deck internally, and this is the outline of that area, so I can use this deck definitions that way. Just makes it easier. You can click in the bays, but I don't like doing that. I think it's much better to do it as a whole like this, so I can call out this whole area, and now it's a fully connected polygon. Makes it a little bit easier under the hood, so I do recommend that. So let me go ahead and go and do this way here. So let's see, grab it like this, and then now I'm selecting everything inside of here, and if I can grab that whole area, I'm going to just call this an angle from the Z direction. That's the horizontal. It's going to be 135 degrees, and then I can go ahead and say box within this area, and I see that overrode it. So I have two decks that overrode the default deck, and that's what's controlling the direction of those areas there for the load attribution. Okay, now we can keep going up the structure. So we're currently sitting at our floor elevation of 72 feet. So we want to keep going. So let's go ahead and say insert floor. And this floor level, we're going to make sure to copy from that floor level 6. We're going to go up from 72 to 84. And we can copy everything that we had there. That's fine. Say okay. And now this is going to be our 84. Now the last floor level we're working on is at 96. So we can say insert floor. Now 96 is going to be a very different looking floor. So things you want to take up this level may be something you want to think about before you push the buttons. So we are going to be at, this is going to be a copy of 96 feet from the last floor level we just did. The columns and the beams, there's a lot of stuff. This is like a portion. It's going to be just like the small portion of the rooftop area. It's not going to be any of this stuff. So I could spend time deleting all that, or I can just not bring that up. So maybe just not the columns, not the beams, nothing really, just maybe the walls, because it's just nice to have that carried up. So I'm just going to carry the walls up from below, and that's it. Maybe I'll change this to be roof because I know it's going to be a roof there. And I know it's not going to be a composite deck. It's going to be metal deck on this level. So I can say okay, and I just get an outline of that. Now, the other piece I want on this floor level is a DXF underlay that makes sense. Remember, we used our DXF underlay in the lower level, but I actually have another DXF underlay for the roof level that I want to bring in, so it helps me guide me what I did. So I'll go up to that top floor DXF I have defined, and I'm going to go ahead and put it in there. Actually, before I do that, one little thing, remember it goes over here. I do want to make sure I set that up properly into the right location. So 180 feet location and 210. That's kind of where my building lays out instead of that. So I'll go ahead and do it this way, and I'll put that in right there, and I'll use this. There we go. Okay, I can change colors on all that, no problem if you want it. It's right now, remember it's gray. If you want to use it in some other level, you can change the colors, but that gray is fine for me right now. We're only going to use it for a few things. So the first things you're going to do is I'm going to put some columns in the model to help me lay out this column. So the columns are going to be gravity columns. This is just really kind of the rooftop equipment area. So not much is going on in here, just going to be a few columns that we're going to carry across. So there's a column in this direction here. I'm going to actually undo that. This is going to be, my column is going to be at 0 degrees. And I'll go ahead and put that right there. And I'll go put right here. Oops, I put it a little bit over. I'll put a column right there. And then I'm going to put columns in here. Now I will frame everything to tie into the rest of the structure as soon as I've laid all of these out. Okay. On this level, I'm going to have some outriggers. Outriggers are going to be similar to our rest of our system, our cantilevers, but they're going to be off of a column. So to start with just drawing an outline of where things are going, I'm going to just tie things together. So I'll go ahead and tie all this together based on what it is right now. And then I'll go around the structure of all of these things. There we go. The outrigger is going to be, when I drew in that cantilever, I can draw in an outrigger. And the outrigger is going to be a length of a certain distance here. Our outrigger is going to be like 7 feet, which is just the distance from here to here. And it's going to be 90 degrees from the horizontal, right? So that's was horizontal was across was 0, 90 is vertical. So I just push that and I can click on any column to create these outriggers. There we go. And then I connect those outriggers. So I just draw in these beams here. I'm just going to connect in non-composite beams across here. So we go ahead and drop these all the way across. So I just maybe click on, there we go. Okay, this also will have some infill framing. So I have infill framing in all the areas. This is a little tighter. This is going to be a roof area. A little metal deck isn't going to span as far. So I'm going to change this to be 4 feet on center. It's going to be horizontal and it's metal deck. And I can choose a few things. So this is small, a really small range here. So I'm just going to say it's going to be wide flange in this area. Maybe, oops, and that's not vertical. We want it to be vertical. So I'm going to do that here. Maybe you could have done maybe channel or something small in this area. But the backspan, what I want to show you guys is steel joist in that area. So I'm going to change that to be steel product. Now for steel product, you can choose a steel joist, or if you know you're going to use a K joist, I know I want a K joist, so I'm going to use that there, and I can just click right inside of that to infill all of that area. So it's framed out with wide flange. You could have drawn in steel joist that way, but it's up to you on how you want to make that work. I like to have it framed out like this, so we can go ahead and drop in our diaphragm edge. On this diaphragm, I'm going to change this to be flexible. You'll notice the color is a little bit different just to help to indicate that it's flexible versus a rigid diaphragm. On the lower level, one level below, this level and the level below that, these are kind of my diagonal areas here. I'm going to change their diaphragms to be a little bit different. This is going to be a semi-rigid diaphragm. So I can do that right inside of the spreadsheet. You can do it manually as well. And then you can change the thickness and the material of that. And I'm going to leave that kind of to the next stage here, but you can adjust all of this material for the semi-rigid diaphragm to be whatever you need it to be to match the thickness of the analytical plates that you'll be designing inside of the FEA model of the semi-rigid diaphragm. So we've got all of that in place. One of the other big things to talk through is the member design rule. So our whole model is done, really. It's modeled, it's finished, it's ready to go. There's a lot of things, we've counted all the forces down the structure and we're ready to start to design it. Now, what did design mean? I want to talk about the design portion before we start to run the model. If I look at the member design rules, what you'll notice here is that we can define some depths and minimum widths and things like that, even maximum bending checks. So in order to get a good design, I want the program to tell, I don't want to get a design that's too deep or too shallow. So I would want to go in and define different things in here. Tell the program, for example, that I want to have everything. I don't want to have anything with a depth lower than 8 inches, but I do know later on I'm going to want a brace, and the brace is not going to want 8 inches depth, minimum depth. And the reason why I say minimum depth of 8 inches is I also am going to use RISA connection, and I know using RISA connection sometimes it can be tight to get in all the bolts I might need for a 6-inch wide flange. That can be a hard thing to do. So you can define those things. You can change your deflection criteria. Deflection is a lot of times going to govern your design, so it's important that you get your deflection criteria set the way you want it to be in here for your beams and for your live load and live load plus dead load and all the categories that you might be interested in and concerned about. This is going to be typically your building code design, right? So you have that. Also camber, we're going to see camber in this model, and it's going to be controlled based on these rules. So whether you have a minimum camber or a maximum camber is defined here, and the length of the beam before we even start to consider camber is at 30 feet right now. So pretty much when all of the long span stuff will maybe start to camber if it's needed, but it's going to be based on the settings we have here, either total dead load or just the superimposed and self-weight load, the percentage of dead load that we're applying on that too. So I'm going to go ahead and run this model, and we'll walk through what we see with the results. So each member in this is going to be designed. It's counting the forces down the structure. We're going to be seeing that it's going to design and optimize all of the columns and the beams. Everything is working towards the most optimal solution. It's going to also be doing the reinforcement for those wall slabs. This just tells us here that we would want to resolve for the analysis. We have a heavier shape than was selected. So in order to count that self-weight, we want to rerun the model. I'm just going to say okay for now, and we'll come back to that. If there's any notices in here telling us a little bit more information, this is a good place to start here, but I'm going to jump right into the model and understand what we see. So first thing is on these lower levels, we see composite steel design. So I have a wide flange shown. It shows me in the parentheses, that's the number of studs that are there. I can pull up, the first thing I always like to do is look at a detail report to know what's going on in a typical design of these. The detail report shows us the loading information, so you can turn between categories or load combination to understand what kind of loads went into that member. Whether it's got what the number of studs and whether it's shored. It tells you the shear and moment diagrams here, the deflection of this member, if there was any axial, so if we had any slope to the model, we would see that there. And then it breaks it down into reactions and distributed loads, and then you scroll down below that and you see composite and non-composite design shown here. So the program is going to be designing it right here now for composite design. We're going into composite bending. We have a checkbox in here that forces composite or says use non-composite if optimum. So if you ever notice that you don't have composite selected there, it's because you've got that checkbox turned on. And this will also note, this gives all of the parameters for the composite behavior. So whether you want to have minimum maximum composite behavior, you have the number of spacings for those studs, whether you're doing a segmented or uniform distribution of those studs, all these parameters are going to help to define what happens in this composite design. And below that here, so now we typically see that really our deflection actually is controlling in this case. We see 90% deflection capacity in this model, this one member. So we're really designing this based on the deflection criteria, and then we get vibration analysis. Now what I want to see too is that I can do the same thing by clicking on the design button. I can answer some of my questions about why I got a 12 by 14. Well, how come I didn't get let's say, a 10 by 12? Well, I can see right there, it failed the deflection ratio, and that's why I didn't pick that. I could have gotten, well, that's a lot of studs too, 22 studs, and also it failed the deflection ratio, right? So you don't want, sometimes what is better? A smaller beam or a better stud? So this is a lot of studs. I think that I'm happy with what it was selected there. But I can force it to be larger or smaller. You'll also see that I can see different things when I look at a girder. A girder is going to be segmented right now because of those composite settings I have, and it's telling the program I'm going to use a 4-2-4, but if I wanted to try to use a uniform, I could force a uniform on that, and it will choose that instead. So I have some design tools really helpful for me to dial in my design of my composite beams there. So my model shows me all of my results, just like in my data entry. I have beam spreadsheets, and I can make mass manipulations of everything in a beam spreadsheet or a column spreadsheet. I also can see results in a spreadsheet format. So if I wanted to look at the end reactions of all of my members and I wasn't interested in looking at a detail report for that, it's too much data, a spreadsheet is such a good way to formulate that. I see all of the end reactions and what is it coming from. So maybe I need to do the design outside of RISA. I can do design of that based on the reactions I'm seeing here. I can see column forces, and in particular for column forces, it's really important to know what kind of column forces you're seeing. That's the maximum base reactions, and this is the load combination that's governing for that. I see at the bottom of my screen I have a load combination here. It describes whatever you are looking at, just so you may want to be interested in that. It says reduction factors are considered for live loads. I can see live load reduction information right here. So the live load reduction shows that it's going to be a what the percentage there is be reduced, and then what is the unreduced force versus the reducible. So you have all that listed per column stack. Another important piece to think about is that these columns in the interior of the structure are really tall. They are 84 feet right now. That's pretty unshippable, right? So one of the things you may want to do is start working on putting splices into your model. So you can do splice design here, and you can put the splices right into a model. I'm going to break the solution here, and I can drop a splice in at any location. For example, I can just put it in roughly at 40 feet, excuse me. But that would be pretty hard to click around the entire structure and do that. So what you can do is go into your column spreadsheet and go to maybe your third, let's see, that would be your fourth floor. Let's go up to that one. And you'll see I put a splice right there, and it defined it here a distance from that elevation. So if we were thinking about this elevation, that means that I would be at, let's see, 30, we want it to be at 40, so I'm going to actually want it to be 4 feet above that floor elevation, so this would be 4. So I could turn on the entire floor level, have a splice in this location, just say fill the block, and I could put a splice there, and I could use a default elevation there, and I could just tell it to be 4 feet. There we go. So it will change all of that to be 4 feet. You can adjust that to be a moment splice or a shear splice. It's up to you. The program is trying to be smart for you. There is a spliced location here in the floor spreadsheet. So if I would to change that there, I would have just set it to be 4 feet, and that would have used the default location. Maybe if you do some thought ahead of time before you draw that whole model, you might want to do it there. I typically think about the splice after the fact, but it's up to you how you define that. So you can see I've got this now at 40 feet right there. Splices can be deleted. Maybe I say, well, this one's good enough. I can come in here and just delete that splice. Maybe I'll cancel out of that. But you can see you can do anything. What is nice is it's graphical, still on your screen, but you can also do it in a spreadsheet. Another cool thing is if you double click on a beam there, you can see it has a very similar input to RISA 3D. So you can adjust those different things, whether it's pinned, whether it's going to be an explicit or a shape group, what the design properties of that are. You can make that definition right there. Also, before we keep going, I want to kind of go up here. One of the things we didn't review our steel joists yet, but what I do remember is I forgot a parapet. Now, parapets are really important in this model because if you're thinking about walking around out the door of one of this little area, you're going to be on to the next floor level, which is going to be this level, and you might just fall off the edge, right? So you want to make sure you have a parapet edge around that. And so you can do that. We can change a parapet either manually, or we can do it on a spreadsheet basis. So I actually like to do it graphically so we can see that. So I can go ahead and say columns, and I can just go ahead and add a parapet to everything we're looking at. So I will go ahead and say I'm going to change this to be a parapet height of 4 feet on every single one of these columns. And I'm going to say apply to the entire all selected columns. And it will then use that there. I can verify that by just seeing this, zooming in, and I see this edge here has now been applied to this whole floor level. It only did it to the outside. It's really smart. Just like it knew the perimeter columns, it knows it like that for the parapets as well. Okay, and then you could even double click on a column and you'll see it just goes right above that level. So it's just 4 feet above. So we've got kind of a layout now of everything, and I'm just going to run that model one more time. And at this point here, I really want to refer to my steel joist design. We haven't really made many changes to the model, but we did do is go ahead and we made some adjustments, a little bit of changes, but it is running through a full optimization to make sure that we have the best solution yet again, so that I don't end up with a model that is slightly changed but not adjusted. So I'm going to go all the way to the top level, and I'm going to see some of the things that are happening in this level. So when I have a joist design, I can look at a detail report of a joist design, and it's going to be very similar to what we just saw for a beam. We have a shear and moment diagram. Again, these shear and moment diagrams are interactive, just like in RISA 3D, so you can see that. But you can scroll down below. Mostly what joists care about is a uniform distributed dead load and a uniform distributed live load. It's a UDL or ULL, and then we turn that into a load here that we look up in the joist table. So if you're seeing anything that's you've got here, it tries to figure out what's the joist capacity, and right now I'm using a 12K1, so we see the capacity of that, and we're going to fit that inside of that total capacity, and then we try to back into this calculation of the deflection and to find the most optimal joist for you in those situations. So you've got the joists running across there, and you're sizing them as you need, as well as your wide flange results right there too. Lastly, I want to kind of jump into that camber area. I think that was kind of a cool one. That distance right there is going to be a total distance of, and I'm going to measure that. That currently is 67 feet, really long. But we do, let's see, I should have gotten a camber. I see a camber on this guy. Oh, there we go. 3 inches of camber. That's a lot. I'm also getting camber on these guys as they're going a little bit longer too. So the program's going to try to get that. If you decided you did not want to, you can uncamber those, and you can probably start to break this up. This is a really long beam, but it might help you to design it if you need to if you're not able to ship that long of a beam like that. You've got a lot of different options to get these real long ones going. But now, kind of at this stage, we're fully designed it every way we can. We can do walk through anything we need here, but we want to then go into RISA 3D. So after we've gotten all this set, we're going to use our director tool, and we're going to move into RISA 3D. Thank you for viewing this session of RISA Steel Building Workshop focused on RISAFloor. When you're ready, please proceed to the next video, which focuses on RISA 3D.